Welcome back to the deep dive. Today, we're opening up a stack of sources that show us exactly how artificial intelligence is moving beyond the screen
Right.
and, into the actual structural steel of the world around us. We're talking about construction.
Specifically AI-driven generative design.
Exactly. And how it's fundamentally rewriting the rule book for building layouts, moving, well, far beyond traditional manual design methods.
That's right. And the mission for you, the listener, is really to get a quick handle on this shift. We're going to distill how this innovation acts as a kind of shortcut, a powerful one, for optimizing building layouts.
From the very start.
Yeah, from initial concept right through to the blueprint.
Yeah.
And critically, we need to understand the parameters the AI is using, which can sometimes even compete with each other.
Okay, let's unpack this then, because we're not just talking about simple CAD here, are we?
No, not at all.
This is synthetic intelligence doing complex optimization. So what exactly is the tech behind this? And maybe more importantly, how is it finding designs that, human designers might just miss entirely? That's what we need to get into.
Okay. So at its core, AI-driven generative design uses these sophisticated algorithms, things like evolutionary solvers or maybe deep reinforcement learning systems.
Right.
And they generate and then test optimized layouts. It works based on what we call fitness functions. You tell the system your goals, your parameters, your constraints.
That's what you need the building to do.
Precisely.
Yeah.
And the system then just rapidly iterates solutions, thousands of them, scoring each one against those functions you set up.
So it's not just drawing what I asked for, it's treating the design like a math problem.
Exactly. A math problem to be solved against a whole set of objectives, often at the same time.
Which is different from how humans work, usually.
Well, the real power comes in balancing those conflicting objectives simultaneously. Traditional design, often forces compromise because a human designer can only really track so many variables effectively at once.
Okay, so when we talk constraints, what kind of technical factors is the AI juggling? We know space and cost, obviously, but what about the actual physics?
Right. Good question. The sources detail how the AI has to weigh things that naturally conflict. For instance, you might input a parameter to maximize daylight,
Okay.
which usually means bigger windows, maybe thinner supports. But at the same time, you demand compliance with tough fire codes and structural load requirements.
Ah, okay. Those fight each other.
They do. And you might layer in the site's unique microclimate data, too, analyzing solar gain on one side, wind load on another. The AI works through this multi-objective optimization, proposing solutions where maybe human intuition might have just defaulted to a standard, less optimal shape.
That's an incredible. 1,000,000 trials in an afternoon, you said earlier. That must completely change the game for trying out radical designs.
It does. It lets firms explore territory that would just be too expensive or take too long with traditional methods.
Okay, this leads us right into the 4, let's say, tangible ways this capability is changing design delivery. These are the core benefits for you, the listener, looking to get this knowledge. Think of them as the 4 pillars of optimization AI provides.
Pillar number 1 is just sheer speed, faster design iterations. The velocity element is truly transformative. It changes the whole workflow.
How so?
Instead of a designer spending weeks maybe coming up with 3 workable concepts, the AI can generate thousands of performance-verified alternatives.
Thousands.
Thousands in just hours.
And these aren't just random shapes, right? The quality matters.
Exactly. It's not just sketching. The AI is testing them against real-world criteria simultaneously. Every option is instantly checked for structural viability, thermal performance, even zoning compliance.
Wow. So performance modeling is baked right into the design itself.
That's the key difference. It drastically cuts down the time and cost of that initial concept phase. It lets the human team focus their energy on refining the absolute best solutions rather than just generating possibilities manually.
That speed then connects directly to the second pillar, enhanced space utilization and material efficiency. Practically speaking, this means getting more usable space from the same footprint.
And this is where the AI really shows its worth by using geometry that maybe human designers tend to avoid.
Why is that?
Well, traditional construction loves simple rectangles, right? They're easy to calculate, easy to build. Generative design, though, it excels at non-uniform, optimized geometry. Think like organic flowing support structures.
Like you see in some newer bridges or stadiums.
Exactly. One study we looked at showed a big commercial project used generative design and cut its steel load by nearly 12%.
12%, just by using different shapes.
Yep, just by using AI-suggested non-uniform trusses that precisely minimized material where the load was lower. It put the material exactly where it needed to be and nowhere else.
That reduction isn't just about looks. That's direct savings on materials and time on site.
Precisely. It's inherently more economical, and it leads to layouts that just eliminate wasted space by maximizing the functional density. Every square meter is working harder.
Okay, pillar number 3, sustainability. And this isn't just, sticking solar panels on the roof. This sounds like deeper data-driven analysis.
It is. It's optimization with environmental goals built right in from the start. The AI analyzes very granular environmental data.
Like kind of data?
Things like localized wind speed, shadow analysis across the day and year, historical rain patterns for that specific site. By running all these thermal and structural simulations, the system suggests geometries, materials, building orientations that are inherently more energy efficient.
So it might suggest, what, turning the building just a few degrees or changing a roof angle slightly?
Exactly. If the data shows a measurable improvement in thermal performance, it'll propose that. It often results in a significantly lower life cycle carbon footprint for the building.
And it goes beyond just energy use.
Oh, yeah. It addresses materials, too. You can constrain the AI to prioritize low-carbon materials or maybe resources available with a certain distance, factoring in the embodied carbon of the supply chain itself.
That sounds incredibly powerful. But it brings up a practical question for Pillar 4, cost efficiency. Reducing waste sounds great long-term, but what about the upfront cost? Is there a hurdle with the complexity, the computing power needed?
That's a fair point. The sources do acknowledge the high computational needs, especially at the start, but they really stress the rapid ROI, the return on investment.
How so?
Generative design optimizes cost primarily through that material reduction we talked about, minimizing waste, but it also helps by optimizing how standard parts fit together, even suggesting designs that are better suited for off-site prefabrication.
Ah, okay. So it connects the design not just to the building structure, but to the logistics of building it.
Yes.
If the design is tailored for prefabrication, that could cut down massively on expensive, tricky labor hours on the actual construction site.
Absolutely. By maximizing resource use and minimizing surprises during assembly, it delivers, well, better quality design while pushing down both construction and long-term operational costs. It hits the bottom line.
So we've established this tech is transformative, and it's not just theory. Leading firms are actually using generative design now.
Oh, yes. For huge residential, commercial, industrial projects. It's happening.
What's really interesting is the scale, right?
Yeah.
Especially in urban planning. The sources highlight AI enhancing urban livability, not just one building, but whole districts.
That's where it gets particularly fascinating. Optimizing not just a single structure, but the interactions between them.
Okay, but urban livability. That sounds quite subjective. How does an AI actually measure something like that in a city?
It does it through massive data ingestion and simulation. To optimize things like building heights, yes, but also light access for everyone, and crucially, pedestrian flow.
How people move around.
Exactly.
Yeah.
The AI takes in millions of data points, traffic sensors, anonymized mobile data showing movement patterns, detailed microclimate models for the streets. It simulates how people would naturally move through and interact with the planned space.
Wow. So that kind of analysis can spot potential bottlenecks or maybe awkward public spaces that a human planner might miss until it's already built.
Pretty much. It's like predictive modeling for social infrastructure. It can lead to different path designs, better shading, building placements that ensure more equitable light access for neighboring buildings. The result is cities that are just inherently more functional and pleasant to be in.
The consensus in the sources seems to be that the potential here is, well, almost limitless as the AI models keep improving, especially when you look at future integration.
Yes, this is where the real acceleration happens.
Yeah.
If we connect generative design to the bigger picture, it's set to integrate almost seamlessly with two other major forces in modern construction, 3D printing and BIM.
BIM, building information modeling. Many listeners will know it, but maybe remind us why linking generative design specifically to BIM is so powerful in this context.
Okay, so BIM is basically the central digital hub for all the project data, right? Geometry, engineering details, costs, schedules, relationships between components.
Got it.
When the generative design system spits out an optimized layout, that design can immediately and automatically update the entire BIM model.
Ah.
So every single iteration the AI generates instantly updates the bill of materials, the construction schedule, everything downstream.
That's huge. It bridges that old gap between the design team and the logistics and construction teams.
Precisely. And then if you connect that constantly updated BIM model to execution technologies like robotic construction arms, or large-scale 3D printing,
You close the loop.
to close the loop, the optimized design is literally connected directly to the construction execution instructions. That connection just eliminates a massive number of potential errors, delays, and miscommunications that plague traditional building sites.
Okay, let's bring this all home. The main takeaway seems simple, but really profound. AI-driven generative design is a genuine game changer. It offers faster, much more efficient, and more sustainable ways to create optimized building layouts,
Mhm.
which means higher quality buildings, lower costs, and less environmental impact.
Which raises a really critical, maybe provocative question, something for everyone listening to think about, especially if you're in design or architecture.
Okay.
If AI can integrate this design optimization directly with construction execution, like 3D printing and BIM, where the design is automatically verified, scheduled, even built, how does the basic role of the human architect shift?
They won't be sketching floor plans anymore, that's for sure.
Absolutely not. Their highest value moves away from that manual iteration. It moves towards defining the strategic parameters, the constraints, the goals the AI needs to work towards.
So deciding what to optimize for.
See, exactly. The architect of the future won't be drawing the optimal building. They'll be defining the ethical and functional weighting of the problem. Deciding, should the system prioritize minimizing material waste at 70% importance and maximizing light access at 30%, or the other way around? That shift from drafting to strategic parameter setting, that's where the real human creativity and value will lie next.